Now we will see flow control in TCP. We have seen theoretical ideas about go back N protocol and SR protocol, right? But TCP won't use exactly go back and exactly SR protocol. It uses hybrid version of that. That means it takes some of the ideas from go back N protocol and it takes some ideas from SR protocol. That's why I can say TCP flow control is different from these two. We can say that it is a hybrid version of go back N and SR. We will see exact details of flow control. How flow control happens in TCP. The only thing you should understand is what is the window size here. So here in TCP, let's say this is your one end, this is another end, okay, A comma B. Let's say client and server, otherwise we can say two hosts, okay. Now A and B, whenever they want to communicate initially, so example, there will be two buffers, okay. A is going to have two buffers, B is also going to have two buffers. So this buffer combination is for one-way communication. That means A to B communication, and this is for, let's say, B to A communication. We only try to understand A to B communication in the same way we can understand about B to A buffers. That's why let me focus on now only A to B data transfer and the related buffers. So similarly we can understand about B to A, not a big deal, okay. Now initially what happens is this, let's say whenever A sends, because let's assume that A is sending SYN packet to B, okay. So A opened connection to B and B has to reply for that, okay. Now how B is going to reply, we will see. There will be application program, right? Here that application process will tell like this: my dear B, someone asked you to open the connection, right? Now for that what you do is, for especially for this connection, so the buffer size should be 500 bytes. So don't go more than that. That means I'm giving you 500 bytes. Don't exceed it. Please tell him also. That's why whenever A sends SYN packet like this, then B is going to send acknowledgement, right? And SYN plus ACK, we know that, right? That SYN plus ACK looks like this: SYN and ACK. I show only now one more field, that is receiver window. We know that in our TCP header there is a receiver window size, correct? So RWND, receiver window. So that receiver window size should be, that means the value should be 500, and we send it. Whenever it is received by A, then it will understand that, so yeah, B accepted my connection, and he said only 500 bytes is the maximum size. Immediately, so after receiving this one, A is going to fix his buffer size for A to B communication, that is 500 bytes. From now onwards, A should not go beyond that. Understand? So now A and B will agree on this 500 bytes. Now we'll see how to agree on 1000 bytes. Same story. I will explain with 1000 bytes. Everything is same, but just for repetition. Initially, A sends a SYN packet by saying that please open the connection. Then B will inform application layer. My dear application, someone wants a connection. Okay, then immediately application layer gives you parameter. My dear TCP, you can go for up to 1000 bytes. That means the buffer size you can fix exactly 1000 bytes, not more than that. Okay, we have only that much resources for that connection. So immediately, so B is going to send that with SYN plus ACK packet. This is, let's say, SYN and ACK packet, SYN and ACK. And here there will be a receiver window value. Here we can fix 1000. When it is received, then immediately A will understand that connection has been opened and the window size should be 1000 from now onwards. So A will maintain that buffer or receiver window size as exactly 1000. So from now onwards they will work on this 1000. Now we'll see how this 1000 will be used effectively. We will see. Now A and B agreed upon 1000 value. Okay, this is the window size, I can say 1000. B also uses same exactly 1000 size. Now how they are going to use this value, we will see. So since already connection has been established, right? Now A is going to send data packets. Example, let's say A sends a data packet like this with some 500 bytes. Okay, then whenever it is received here, so B is going to take that 500 bytes and it is going to keep here 500 bytes. Now it is going to send acknowledgement. So that ACK looks like this. Okay, my dear A, whatever the data you sent 500 bytes, so I'm acknowledging it. I'm happy with that. But you see one thing, so far my application layer is busy. He did not take that 500 bytes of data. I said you that window size 1000, but you see now my only, I can give you 500 bytes of space now. So immediately it will advertise 500 here. Then this will be sent. Right? Now you see this situation. Already A knows that initially what is the window size 1000, but among that 500 already he sent. Correct? Now he also understands that he cannot go beyond 500 bytes. So he will also remember that effectively I can send only 500. Then after that this acknowledgement comes. It says that only 500 is the effective window size. So now after receiving it, before that also he knows that, then he will send one more 500 bytes. What is going to happen, we'll see. So this is sender side calculation. I already sent 500 bytes. Now I am sending 500 more bytes. Now effectively I should not send anything. So one more set of 500 bytes will be, let's say, sent. Then what is going to happen? They also will be taken by your receiver. Why? Because receiver said I accept 1000 bytes. Only 500 bytes it has been accepted, then it will take 500 more, then now 1000 bytes buffer is full. Now by this time your receiver is going to send acknowledgement like this. My dear sender, this is acknowledgement, but along with that I am advertising my receiver window. That receiver window size is 0. Don't say anything more. So in that way, so receiver is going to send that, of course, but already your sender knows that, correct? After some time what happens, we'll see the story. Now sender will keep quiet because receiver said only 1000 bytes, sender sent only 1000 bytes, right? Now eventually one day your application will consume the bytes, correct? So application layer is going to take some of the bytes from this TCP buffer. So assume that, let's say that application took 500 bytes. 500 bytes are consumed. Then your buffer will be free, right? Okay, here there will be 500 bytes. So whenever at this moment it is going to advertise, one packet like this, maybe ACK packet, otherwise any data packet. There are some of the data packets which are going from B to A also, we know that, right? Because it's a two-way communication. So in one of the packet it is going to send like this. This is my data, but at the same time you see one thing, see this information, this is receiver window size, right? Now already my application layer took 500 bytes, see now. So this will be sent. Whenever it is received, then your sender will understand that current window size is 500, then this space will be empty, correct? So now your sender will understand that we have 500 more bytes to send. This is already full, okay? So now new data will be sent. In that way, sender and receiver is going to communicate. It's very simple. So receiver will advertise his current window size. We should not send more than that. Okay. Now we'll see one of the possibility which should not occur, that is shrinking the window at receiver. That means receiver window should not be shrink. Okay, we will see that. What does it mean? Initially, let's say both are agreed on 1000 bytes of receiver window size. Initially, that means receiver advertised receiver window size as 1000 bytes. Okay, now you see the situation. Let me ask some questions. What if sender sends some 500 bytes of data? Then what happens at sender? How sender will understand the remaining thing? Simple. He will mark like this. That means I don't touch this part. That means out of 1000, 500 bytes are already I sent. That's why I should not send now more than 500 bytes. So this 500 bytes will be the bytes which he can send. Okay, I'm just focusing on the size of the bytes which we can send. Now here receiver side, receiver will add that 500 bytes here. Now if application layer immediately takes them, it consumes, then still receiver window size he can advertise 1000 later. But assume that, let's say application layer is busy, then what is the maximum number he can advertise? Only 500, receiver window 500. Then it is compatible. Even sender is expecting to send only 500 bytes, you are also sending receiver window size 500. But ever do this one, receiver window, never do this one, receiver window size 200 now. So after getting 500 bytes of data, don't advertise receiver window size to 200. That means, so sender is expecting to send 500 bytes, but you are telling that send only 200. But initially we agreed upon 1000, correct? Out of that 500 I have sent, then this 500 bytes I thought of sending, but you are stopping me. But before you send that receiver windows 200 advertisement, what can happen is this 500 bytes he would have sent already, correct? So that will create the problems. That's why the simple rule you remember, sender and receiver, once they agree on some buffer size, that should not be effectively shrinked. That means since sender send 500 bytes, then we should advertise our receiver window size to 500 or more than that, but not less than that. Okay, that is one thing you remember. So far we have seen flow control. Flow control is all about how receiver window will be advertised by your receiver, right? Based on that we have to send. Now before going to error control, we see one problem, that is silly window syndrome. What is this silly window syndrome? We'll see. In silly window syndrome, it can occur at so many places. First of all, we start with the sender. Sender can have a problem called silly window syndrome. What is that? We will see. See this situation. Sender is very slow. That means application layer of that sender may be very slow. That's why TCP is also very slow. This is application layer. This is TCP. Okay. Now application layer is sending only 1 byte of data. Here I would like to ask one question. Whenever A sends, that application layer gives 1 byte of data, should I create a segment immediately? Did you remember? Actually we have to create segments and we have to send, correct? That's why we have headers. Every segment will be created, but I never explained you how this segment will be created. What should be the size of the segment, correct? So we know the maximum segment size. The maximum segment size should be such a way that should fit in your IP protocol, that means IP header. Such a way we plan it, that maximum size. But should I always go with maximum segment size or anything else? We will see. See the story. First of all, let's say sender A application layer creates a message. Okay, but only 1 byte. Now whenever 1 byte is created, and immediately you go and create a segment, that is worst case possibility. What is the problem? I will tell you with this. So you take every byte and create a segment. Then what is the header size you are adding? We know that TCP header size will be some around 20 to 60 bytes, isn't it? So this 20 to 60 bytes of data, and we are adding network layer header, correct? After that we are adding what? Data link layer header. In that way so many headers we are adding just for 1 byte. Now if you see, at least 100 or 120 bytes of header will be added, but only 1 byte of data. So if you see end-to-end communication, this is TCP layer. Let's focus on this TCP layer. So in the TCP to TCP, if you see, only effectively 1 byte will be transferred. But in the network, if you see, hundreds of bytes are transferred for 1 byte. So definitely throughput will be reduced and it will create congestion, right? Because 1 byte is creating 40 to 100 bytes of header, which is just control information, not a meaningful data, right? To avoid that, what should we do? Think about it. Definitely the data size should not be 1 byte. But sir, why we create 1 byte? I will tell you the reasons why. What is the necessity to create 1 byte of data? Application layer gave us, let's say we are TCP. Application layer gave us only 1 byte of data. After that it kept quiet. It's not giving anything more. Then now as a TCP, I have a doubt. Should I wait for more data? Otherwise should I send 1 byte? If I send 1 byte, so I am going to create lot of overhead, right? That means I am going to reduce the throughput, otherwise I am going to reduce the increase the congestion. To avoid the congestion, I will wait. But if I wait, there will be delay. When there is a delay, then definitely performance will be decreased, correct? What is the ultimate goal of your computer networks? We have to send the data as fast as possible, right? That's why if you wait for your application to send more bytes, then definitely we will be wasting, the delay will be increased. To avoid the delay, we should send 1 byte. That will create congestion and everything. Still again, that will create the delay again, correct? So that's why what to do here, right? So if you, let's say your application is slowly giving 1 byte, let's say keep a timer. After this timer, I will tell you what is this timer is called. So let's put a timer. This timer, whenever it times out, okay, whenever timeout event happens, then whatever the data you have, immediately you send it. That means Example, let's say I keep some 30 seconds of, not 30 seconds exactly, let's say 1 second timeout period. What I do is, whenever application layer gives me 1 byte of data, I don't create a segment. I wait for 1 second. After 1 second, still there is no supply, then immediately I create a segment, okay, and I'll send it. This is very important, right? That's why here I use push button. I say that, my dear receiver, already I wasted lot of time. It is created by application layer long back, but I was waiting for few more bytes. That's why, I wasted lot of time. Please, you also don't waste your time. So whenever this segment comes, immediately please send it to. That means simply you don't buffer it. Correct? Directly give it to application layer. Okay. Disturb application layer and just give it. Whatever that application layer do, that's a separate issue. But immediately you give it. Okay. So that's why we use push button. Whenever a button push is set, or whenever the flag push is set, that means your receiver is not going to buffer it there. It will simply directly give it to application. This is different from urgent. So urgent is different. Whenever urgent bit is set, then that is also immediately given to application layer, but application layer is going to by seeing this urgent data, it is going to do some important actions that depends on application layer. It's like really urgent data, but this push is nothing but, so it is just to push the data. That means to say that we should not stop it, we should send it. But that is different from urgent data. So urgent data is generally, that urgent is created by application layer. Application layer says that, my dear transport layer, I am giving some urgent data, give it to immediately to that application layer. At that time we put urgent field. Okay, so that is different from this one. Push is generally used for this purpose. Okay, remember it. So in one line, you remember, generally whenever push, I can say push field is enabled, then that corresponding transport layer at receiver side is not going to buffer it. It is going to directly give. Usually, generally, the transport layer buffers it. Okay. So that is the story. Now what I want to say is, imagine the situation, your sender application is very slow. It is creating packets very, it is creating messages very late. That means 1 byte per 30 seconds in that way. Then definitely your timer will become timeout and you are going to send 1 byte data because of the slow sender. Then this phenomena is called silly window syndrome. Okay, silly window syndrome. Remember it. That means to create 1 byte of data, we are wasting a lot of space. When you do that, then we say that is silly window syndrome. In one line, you remember, whenever you are sending only 1 byte of data, that is called silly window syndrome. That means you are very inefficient. Okay. So here, to avoid that, there is a I can say there is a suggestion from Nagel. Okay, we will see that Nagel's algorithm here. What Nagel said, whenever you get this kind of situation, what to do. Okay, we'll see that. Now we'll see Nagel's algorithm. In Nagel's algorithm, so we are going to use a term called maximum segment size. Already I told you what is maximum segment size, correct? So maximum segment size is a segment size which can fit in any datagram, right? Datagram has a limitation, already I told you. So datagram can allow only some sort of, otherwise some size of the data, right? It is around 65,000 something. That exact number you have to calculate on your own. That's why I'm not telling that. So what is the maximum data your IP datagram allows? Please check it out, calculate that on your own. Then that is called maximum segment size. Now remember that maximum segment size. Now according to Nagel's algorithm, what we do is, let's say this is your application. This application is creating the data. So this is your TCP. What TCP is going to do according to Nagel's algorithm is, first of all, whenever 1 byte data is given by application, immediately that 1 byte will be sent first time. Okay. So we create a segment of 1 byte and we send. Then what happens is, so meanwhile your application is going to give more bytes. Now definitely this packet will go and you get acknowledgement, right? We will see how when this receiver is going to send the acknowledgements. That I will teach in error control. So we know that whenever packet is received, acknowledgement should be transferred by your receiver. Then only we can understand that what packets are received by the receiver, right? We have studied that in flow control. that we and error control in our go backend protocol, SR protocol, ARQ, right? ARQ means error control mechanism also. So here also I am going to teach you how TCP is going to take care of error control. Flow control is already done. Now we are just seeing silly window syndrome, right? Now in that one, so your receiver is going to send the acknowledgement for sure. Whenever acknowledgement comes, then by that time, whatever the data we have, we are going to send it again by creating a segment. Okay. Now we will see with some numerics. Example. So initially your application layer is creating only 1 byte. Okay. After that, let's say it stopped. Otherwise, you know what we do in according to Nagel's algorithm, we take only 1 byte, no matter how much it creates, and we create a segment and we send the segment. Okay. After, let's say, some 30 seconds, we got the acknowledgement. In that first 30 seconds, let's say, so your sender sent only 50 bytes of data. That means application layer gave us only 50 bytes of data. But maximum segment size, you know that it is around 60,000. Okay. Now the question. Okay, it's around something 65,000. Don't worry, because I said approximately. I'm not telling exact answer. Let's assume that maximum segment size is 65,000. So my question is, should I wait? Otherwise, should I send? According to Nagel's algorithm, once you get the acknowledgement for a previous packet, immediately you send that 50 bytes. Okay, though it is not a size of maximum segment. Now send it. Now this time, so there is a delay. Acknowledgement did not come. We don't know because it depends on the error control policy. So otherwise you can assume that, let's say this time your application is very fast. It was giving lot of bytes before this acknowledgement comes. Okay. So this sender or application gave you so many bytes such a way that it become more than segment size. That means you accumulated 65,000 bytes approximately. Then according to Nagel's algorithm, this time acknowledgement did not come, but we got so much data such a way that it is exactly equal to maximum segment size. Then immediately send it. Understand? So in that way, so we are going to and wait for acknowledgement of this one. Okay. Now after sending this one, the previous acknowledgement comes, then no problem, don't worry, but wait for this acknowledgement. Whenever it is coming, whenever it comes, by that time, if you have not accumulated 65,000, whatever you have, you send it. Otherwise, if it is more than 65,000, then happily before that itself you can send. Okay. Now finally we can summarize like this. Step number 1, create 1 byte of data, send it. First step in Nagel's algorithm, that is clear, 1 byte. After that, wait for the acknowledgement. If acknowledgement did not come, but before that itself you have maximum segment size data, send it. No sir, I did not accumulate maximum segment size data, but acknowledgement came. Then whatever the data you have accumulated, then we have to send it. Now, once you send it, then you are going to get acknowledgement again, correct? So after sending the packet and before getting the acknowledgement, in this period, there are two things. In this period itself, if you have accumulated maximum segment size at any time, you send it. If you cannot accumulate that much, then wait for acknowledgement. Then if acknowledgement comes before you accumulate maximum segment size, whatever you have, you send it. This process will be repeated. That is Nagel's algorithm. Understand? So now I will give you one example. Tell me what is the decision we should take. Initially you sent 1 byte. Okay. 1 byte. Then let's say acknowledgement came, but it took 30 seconds. And within 30 seconds your application created 80,000 of data, 80,000 bytes. What should I do? So before 30 seconds we have 80,000 bytes of data, then it is more than 65,000, right? Immediately with that 65,000 we create a packet and we send it before acknowledgement. Okay, so if you have only 40,000 bytes, what to do? So within 30 seconds application created only 40,000 bytes, then take that 40,000 bytes and simply send it. That is what Nagel's algorithm. Okay, so we repeat this process for every packet. Understand? So this is about Nagel's algorithm. Now we'll see silly window syndrome at receiver. So far we have seen silly window syndrome at sender side, and the correction for that, otherwise the solution for that was Nagel's algorithm. Now we'll see silly window syndrome at the receiver side. What can happen is your receiver is very slow. That means application at receiver is very slow. It is consuming bytes very slowly. Now imagine this situation. Let's say your application is very fast. Now initially, so we agreed upon 1000 bytes of data, right? That means the window size we agreed upon is 1000 bytes, receiver window size. I am talking about this direction, A to B. Now what happened? So A sent all his 999 bytes of data, okay, and B received all that 999 bytes of data. Now how much space is there in the buffer? Only 1 byte, correct? Then effectively what your receiver is going to advertise about receiver window? 1 byte. So your receiver is going to create a packet saying that, my dear sender, calm down, I have only 1 byte of space, okay? Now let's say assume that your sender now is creating only 1 byte of data because there is 1 byte of space, right? Then with that 1 byte of data he is going to send a packet. Assume that it is received by receiver, then that is also full. At that time what it will do? It will send an acknowledgement or anything, otherwise any data packet also it can send. At that time it will advertise its receiver window by 0. It says that, my dear sender, it's gone, complete buffer you have used now, so my receiver window is only 0. After my application consumes anything, then I will advertise again. So by that time you keep quiet, don't send anything. So immediately at this time, so sender is going to close his window. This is called window shutdown, okay? So window shutdown, A will shut down the window. Sir, when will he open his window again? When advertisement comes from B that I have this much space. Then you see the situation, receiver is very slow, he is only consuming 1 byte at a time. Now assume that, let's say that application at receiver consumed 1 byte. Then immediately, so your receiver is going to send an advertisement, receiver window. How much receiver window we have now? Only 1 byte space, isn't it? Yes, we send this packet saying that, my dear sender, see, you can send 1 byte. Then he was waiting for a long time, right, to send the data. He completely shut down his window. Now whenever suddenly he gets this advertisement, he will wake up and he will be happy because he was waiting since long. Then immediately he will send that 1 byte of packet, okay? Then that 1 byte again will be filled here. Then application layer consumes again, assume that 1 byte. So now it is constantly consuming 1 byte, 1 byte, 1 byte. Then your receiver is going to advertise always, I have 1 byte of space. Assume this scenario, sender is sending 1 byte, that receiver application is consuming 1 byte. Then what happens? Every time your receiver advertises only 1 byte, correct? Then now your sender, because it is very fast, it was waiting since long, then definitely he will send only 1 byte and lot of header, correct? So again silly window syndrome, you are able to send only 1 byte at a time because slowly your receiver is consuming, that's why you are sending only 1 byte per iteration. This is called again silly window syndrome, okay? But both are from A to B only, but first time it is created by application at A, second time it was created by application at B, okay? This is about silly window syndromes, okay? So how to avoid that? Is there any solution? There is a Clark solution. What Clark said is, to avoid this one, to avoid silly window syndrome here, what we have to do is, don't advertise 1 byte of data. Example, let's say you have space for 1 byte, correct? Don't advertise. If you advertise 1 byte, immediately sender will send 1 byte, correct? Then unnecessarily he will create silly window syndrome. Because of that, what happens, sir? Congestion. To avoid that, once your buffer is full, let's say at any time, then your receiver consumes only 1 byte. Rather than advertising 1 byte, then we wait for at least your wait for some time so that your buffer is half empty. Whenever your buffer is half consumed, then we are going to, example, initially 1000 bytes, right? According to Clark solution, wait for some period of time, at least 2 things. Case number 1, wait for some 30 seconds or 30 milliseconds, whatever, some fixed time of time. Generally it will be 500 milliseconds, okay? Otherwise half second. Wait for half second, but this number is not important, we can negotiate, not a problem. Second one, case number 2 is either wait for half second, otherwise at least wait for your buffer is half full or half empty, both are same. Okay, now example, your buffer is half empty, half is consumed by your application, immediately advertise, my dear sender, see now I have lot of space, you send it. But previous windows don't send, that means when 1 byte is free, 2 bytes are free, 3 bytes are free, don't send, either wait for half second of time, otherwise half empty, which one occurs first. Example, half second is done but window is not half full. Okay, that means it's not 500 bytes free, then send a advertisement that, example, let's say you waited for half second, after that also only 300 bytes are consumed, then simply send like this, my dear receiver, now enough, please send 300 bytes. Okay, now second thing, before half second your window is half full, that means half empty, then you have 500 bytes of space, then immediately send the message in that way. So this sender and receiver is going to communicate and going to avoid silly window syndrome. Okay, this is Clark's solution, previous one is Nagel solution, remember this. Okay.